All right, today for bell work, we did a quizzes, and these were the two most missed questions. Let's look at number 3. It was the most missed in my last period as well. Let's look at it. I did make a fix on this on your quizzes. There was a pi in front of each of these because it was missing one. We are finding the volume of the shaded region revolved around the line y equals 3. So we need to know where that line is. That right there is y equals 3. Make sure you can know where a vertical line is going to happen. If we're finding volume, what do? Integrate area. I'm revolving it this way. I'm revolving it around the line that direction. Is this a dx or a dy problem if I'm revolving that way? It is dx because I'm drawing lines perpendicular to the x-axis. Is this going to be a disk or a washer? Washer, because there is space in between the thing I'm rotating and the line I'm rotating around. Okay? And so, if we're doing a washer, we take a pi out. And then it'd be big R squared minus little r squared. Write down the formula. First period when we went through this, students weren't writing down the formula and they were doing it wrong. Okay, so it's big R squared minus little r squared. That's our setup. Big radius. The big radius is always going to include the line you are rotating around and the outside line. So we have to include 3, and which line is going to be the outside line, G or F? G. It's further away from 3. That's the outside line. So we go top minus bottom. The only one that it could possibly be is B. 3 minus G of X squared. Okay, we didn't even do the bounds. The bounds are 0 to 4 because it's a dx problem. The little radius is the inside line and the line we're rotating around. So that's going to be 3 minus F. That's the one we want. Okay, if you set it up correctly, it's not too bad. Questions on 3. Let's look at 5. Which setup would find the volume of the solid rotating around the y-axis? So we're rotating it around the y-axis. That means I've got lines drawn like that. Okay, those are going to be our radius. Why do I need it? Or I'm going to say, is this a disk or a washer question? It is both. Okay, good. I heard a little bit of both. Why? Because if I rotate this thing, you've got this part, there's no space. It's just one big old shape. It's a cylinder down there. But up here, you're going to have a washer because we're going to have a space in between the lines. And so I need 2 separate integrals for it. It's not B or D. I need 2 separate integrals. The first integral is pretty easy. From 0 to 2, it's just a disk. So it's pi r squared. My radius is 2. That is why I have 4 dy from 0 to 2 pi. And 4 dy 0 to 2 pi. We're going from 0 to 2. It's dy because I'm perpendicular to the y-axis. The second part is going to be a washer. If we're doing a washer, it is pi big R squared minus little r squared. The big radius is from here to the line we're rotating around. So 4 minus 0. The little radius is going to go from the g of y to 0. So I'm sorry, not 4 minus. It's 2 minus. I said the wrong number. 2 minus 0 squared minus gy minus 0 squared. It's that guy. This guy, they didn't square the 2. They squared the whole thing. Big R squared minus little r squared. If you write it down, you won't make that mistake on that one either. Okay, the answer is A. Question somewhere on bell work. Any of the other ones that you did that you want me to look at because you weren't quite sure? We didn't do too bad there. Looking at number 2, which integral would find the volume of the bounded area? Okay, or find the volume of the bounded area. We're going around the y-axis. That's my y-axis right there. If I'm going around the y-axis, I'm rotating that direction, so it's going to be a dy problem. It is a disk problem because there's no space. It's my y's are going to be my bounds, so I'm 0 to 1. When I rotate it, it's a disk, so it's pi r squared. I can take a pi out if I want. And then I just need to find my radius and square it. My radius is going to go from the right line to the middle, right line to the middle. Right now it's a y problem. And so in order to solve that, I got to get x by itself. I'll subtract 1. I will flip my signs. And then I will square root. So that is that line right there. It's that line minus 0. So all I have to do is take that and plug it in there. That's why my answer was that guy. Is that right? Nope. Yeah, it's that one because I'm squaring it. Yep, it's that guy. Kind of a weird answer in the end. No, that's not it. Just kidding. It's B. I can't read numbers. Sorry, that one has this square in the wrong spot. Questions there? All right. Up until this point, we have done days where, hey, today is a disk day, or today is an area day, or today is a cross-section day. Now we're putting them all together. This is when it gets difficult. Okay? So for number 1, you've got 3 lines, and these lines are going to be the same every time. You've got y equals the square root of x plus 1. That's the red line. Y equals 3. That's the blue line. And then the y-axis. All right? You are finding the area of the shaded region. Not the volume, just the area. Okay? Write that down on your board and then hold it up. Write down the correct integral and see what you can do. This is a different problem because your brain is now working in a new way. You guys are good at this. If it were washer or disk, your brain kind of already goes there, but it's just area. How do you find area? You just integrate top minus bottom. Okay? We could make this a dx problem or a dy if we really wanted to. You don't want to make it a dy problem because none of the equations are in terms of y. That's the only time you would want to make it a dy problem. Okay? We're going to make it an x problem, a dx, and draw perpendicular lines to the x-axis. From 0 until 4, it's the same line on top and bottom each time. It's red line minus the x-axis. So it's going to be the square root of x plus 1 minus 0. Dx from 0 until 4. If I integrate that, that's going to tell me that region right there. But at 4 then, we are switching. And now we're going from blue to the x-axis. So from 4 until 7, we have a new top and bottom line. That's why we wrote a second integral. And then it's going to go 3 minus the bottom line, which is 0. So it's just 3. That's it. Don't let it be harder than that. Don't forget that you're good at this. And it just looks a little bit different. Questions on the first one? Let's do the second one. There is my shaded region. Again, this is the line. Y equals the square root of x plus 1. That blue line is y equals 3. You've got that bounded region. You're this time revolving it around the line y equals 3. Find the volume. Find the volume when you rotate around that line. Y equals 3. Write it down. Hold it up. We're doing okay. There's some similar mistakes. One of the mistakes that we made most on that one was a parenthesis one. And so let's look at it. We're finding volume. If we're finding volume, we integrate the area. Okay. We're revolving around the line y equals 3. That means I am rotating this way and making it a dx problem because I'm going to rotate it around. Those circles are going to be perpendicular to the x-axis. The next thing, when did I integrate that thing? Well, from 0 until 4. So make sure you have your bounds correct. Okay, that's when they intersect. Those are x values. What shape is it going to make? Is it going to be a disk or a washer problem? It is a disk. So if it's a disk, it is simply pi r squared. Okay, that is all I need. I just got to figure out what my radius is. To find my radius, I'm going from top minus bottom. Top minus bottom. So it is 3 minus that guy right there. Square root of x plus 1. The biggest mistake we just made, about 6 kids made it, is you got to throw that in parentheses because it's 3 minus that whole thing. That is my radius. So all I need to do with it is take it and square it. Make sure that you have 2 parentheses on the back side there. Okay, 1 to close off the square root of x plus 1, and then 1 to close off the radius before we square it. Yes, sir?
With those long columns, consider that the red line was above the blue line. Would it still be top minus bottom?
It's always top minus bottom. When we revolve it, yes, it's going to be on top. The good news is if you revolve it, if you square it, it doesn't matter technically which one's on top or bottom because your negative number would become positive, but we always want to go top to bottom. All right. Next one. Let's look at number 3. Same setup. This time we're revolving around the y-axis. Revolve around the y-axis. See what you do. Let's look. We are taking this thing. We're revolving around the y-axis. So if I'm revolving around the y-axis, I'm getting shapes that look like that are perpendicular to the y-axis. If I'm perpendicular to the y-axis, that makes this a dy problem. Okay, how do I find volume? By integrating the area. My bounds go from 1 to 3, top to bottom, or those are my y values, 1 to 3. Is this a disk or a washer? This is a disk problem. Okay, it's a disk because there's no space in between. So all I need is pi r squared, big R. my radius goes from here right to left because it's dy. So my right line is this guy right here. The left line is just 0. So you could write minus 0 or nothing at all. The right line is square root of x plus 1, but it's a dy problem. So before I plug it in, I have to solve. So I subtract 1, and then I would square it. So y minus 1 squared minus 0. Okay, y minus 1 squared minus 0. Or in other words, y minus 1 squared squared. Okay, writing it out step by step is going to be the best method. Okay, otherwise you'll be like, do I need that square? I don't know. There's some weird double squaring happening. Yeah, you need it because it's right minus left. That's different than the other reason why we need it. Questions on that one? This one's tough. I would say this one's probably the toughest one of the day. We're taking that shaded region. So this line that is x equals 4 is also being used now. We are using this line right here, which is the square root of x plus 1. And we're using y equals 3. We are taking that and we are revolving it around the y-axis. Set up your integrals that you need here. This one's the tough one. Okay, this would be a mean one for them to put, but we did one similar to this on Friday's bell work. Okay, we had a very similar question. Okay, we're rotating around the y-axis. So if we're rotating around the y-axis, we are going right to left, right to left, right to left, and then it changes what's on the right and the left. That is why I'm going to set this up as two separate problems. Okay, we're going to have something dy plus another dy. Is this a disk or a washer problem? Both, because initially there's no space, so this is a disk. So this is just pi r squared. What's my radius going to be on the first one? 4, because it's 4 minus 0, 4 minus 0, 4 minus 0. My radius is just 4. From 0 to 1 is when that happens. Those are my y values. Everybody with me to that point? Yeah. Then we do my second one. Okay, my second one goes from 1 until 3. Is the second part a disk or a washer? Is there a space? There is a space, so it's a washer problem. Okay, so if it's a washer, it is pi times big R squared minus little r squared. That is where we're making our mistake. We throw our pi out in front. We're going to find our big radius. That is the outside line minus the line you're revolving around. So the outside line for the second part is 4 minus the line we're revolving around, which is just 0. So it's just 4. That's my big radius. So I have to take big R squared minus little r. Well, the little radius is the inside line minus the line we're revolving around. So it's this square root of x plus 1, but just like we did on that last problem, we got to get y by itself. So get the problem in terms of y. That is y minus 1 all squared. That is my little r. Y minus 1 all squared. Technically, it's that minus 0, but it's minus 0, so who cares? That is what I'm plugging in here. And it's little r squared, so I need to take that thing and square it. That is my setup. A lot of things going on. A whole lot of squares that are going to throw you off. Write it down. It'll help you out. Questions on that one? That one's the toughest one of the day. Yes, ma'am. Harley. You should never get a negative answer. Now, the good news is if we do discs or washers, when you square something, it will be positive in the end. But if we're finding volume, that is always going to be a positive number. And if we're doing area, it's going to be a positive number as well, at least for how we set these up. Yes, sir?
So just to make sure, like the big R squared minus little r squared, it's all squared also.
No, it is big R, it's pi, because think about what we're doing. To find the area of a washer, we take the area of the big shape minus the area of the little shape, right? The big shape is capital R, the little shape is little r. That was going back a couple days when we did this, right? We did big circle minus little circle. So we just factored out a pi. It's just the big radius squared minus the little radius squared. That's all we're looking at. Does that make sense?
Yeah, so why is there two squares on
It's because one of them is this part right here. That's getting the y by itself. Because when I subtracted this is equal to y, I subtracted the 1 and then I squared it. That's why it looks like there's two squares. But one of them is just telling me the radius. The other one is that thing squared. So it looks weird like you're squaring it twice. But it's because there's two different setups. Okay, try the next one. Take that thing and revolve it around the line. Y equals 4. You are finding volume. We're setting this thing up. Okay, we're doing volume because I'm integrating this thing. I'm going to integrate. How do we find volume by integrating the area? We are rotating this direction. And so my circles or my shape is going to be perpendicular to the x-axis. So it's a dx problem. So I need x bounds. I'm going from 0 until 4. I know it looks weird, but it does intersect at 4. So 0 to 4. What is my shape going to be, a disc or a washer? It's a washer because there's a big old space here in between the shape and the line I'm revolving around. So if I'm doing a washer, it is pi, parentheses, big R squared minus little r squared, because it's big circle minus little circle. We can factor the pi out. We're going to take the big radius and square it minus the little radius and square it. To find the big radius, you are including the line you're revolving around, which is 4, and the outside line. The outside line in this case is the red one. That's square root of x plus 1. We go top minus bottom. So top minus the bottom. Make sure you have it in parentheses, square root of x plus 1. That is the big radius because it's the line we're revolving around minus the bottom. Then the little r. Our little r is this line to that line, the line we're revolving around, and then the inside line. So 4 minus 3, or obviously 1. Questions there? Let's jump to this last one. We'll just do it together here because we're running out of time.
Wait, sorry.
Yep. No, you're good.
3. Does it matter? Aren't you supposed to put it in parentheses or square just 3 square?
It's 4 minus 3, and then I'm squaring both of those things. So it should be just 1 squared. You're perfectly good just to write 1 squared there. Last part. Okay, we're doing that shaded region right there. But this time, that's the base of a solid. Our job is to find the volume where the cross sections are perpendicular to the x-axis, and you got isosceles triangles. They would write it out better than what I just said out loud, but that's the idea. We're finding a volume. We've got cross sections perpendicular to the x-axis, and it's going to be isosceles right triangles. So we're trying to find volume. What do? We integrate the area. I am perpendicular to the x-axis. So if I'm perpendicular to the x-axis, is this a dx or a dy? Dx. What are my bounds going to be? 0 to 4. That's where they intersect. 0 to 4. What are my cross sections going to be? Triangles. What's the formula to find the area of a triangle? 1/2 base times height. Okay, but it's a isosceles right triangle, so what else could we say? Base squared, because isosceles triangles, 2 of them are going to be the same. 1/2 base squared. What's my base going to go from? This line that minus that line, so it's just 3 minus that line right there, which is square root of x plus 1. That's it.